So today's lesson, you are going to use for the remainder of this semester. So if you notice, I didn't say the remainder of the triad. We're going to use this all the way through December. Okay? So through the semester. So this is just going to be a building block that we're going to add on through the rest of the second triad and third triad. So you have to understand this stuff. If you get stuck and you do not understand it, then you need to speak to me at the end of the lecture and get help. So don't make this a lesson that you think you're just going to sneak on by, and if you don't get it, it's okay, because it's not going to be. So if you don't understand it after doing it a couple times, make sure you ask for help. So the first thing that we need to write down, it says the numbers that you can take the square root of are called, so the numbers that you can take the square root of that works out evenly is going to be called what? Like the square root of 16, that answer is considered a, 2 words.
Square root.
Nope. So for example, if I say the square root of 16, what's our answer? 4. That worked out evenly.
4 squared.
So it's going to be considered a perfect square.
Oh. So that's what we write?
So on those 2 lines, you're going to write out perfect square. So what that means is when you're able to find a square root of a number without getting a decimal and you're just given the number, it's a perfect square. You guys are going to come to learn to love perfect squares. The not perfect squares are going to be what's going to be more difficult. Okay? So, the next part of our notes say, the numbers that you can take the square root of are called perfect squares. So we want to go ahead and list the first 10 perfect squares. So what that means, if I ask you guys to find the square root of 1, the answer is going to be 1. Hey, you know what? We're going to have to stop doing breakfast and everything else if we can't focus. All right? I've told you guys multiple times, this is such an important lesson. I need your focus up here. Yes. Yes. So Deja had a good question. Do we write those down? Yes. Where it says the first 10 positive numbers are, you're going to write these numbers. Meaning, if I find the square root of 1, my answer is 1. It's a perfect square. If I find the square root of 4, the answer is 2. It's a perfect square. The square root of 9 is 3.
That just stop us from doing extra work.
What's that?
That just stop us from doing extra work. Like, just find a perfect square.
I just want you to write exactly what I have. Oh, I see what you're saying. So Damon had a really good question here. Does this stop us from doing the extra work that we had to do on our opener? To some degree. And I'll show you what I mean by that in the next couple of example problems. That's a good question.
Can I use a mechanical pencil? And
I don't. If I have one in there, you sure can. Yeah. So make sure you have them down. That's going to be a quick reference. So those are going to be the first 10 numbers that you're not going to have to simplify because they equal perfect squares. Okay, example number 1. Go ahead and write it down for me. So we have the square root of 25. So if you noticed in your notes, the square root of 25 is going to be a perfect square, right? We wrote 25 down. Now let's say that you didn't know that. So what you're going to do, actually I'm not going to make you do that. So the square root of 25, we know it's a perfect square, right? So how do we show our work for this?
Equal 25.
No, we equal square root of 5 squared. That cancels, which equals 5. So I'm not letting you cut down the work there yet, but we'll get there. So that one's an easy one. That's one we already know how to do. Okay, so that one we should know how to do. Let's look at example number 2. Ooh, what is this? Yes, so you write this. So you're going to have the square root of 2 times 2 times 5 times 5. You want to make sure that you always write your example problems out all the way. So that way when you go to use your notes for your quiz, that way when you go to use your notes for your quiz or your test, you'll always have them. I got a tea and a coffee when they come in. I get one free, so I should get $4 change. So, there are multiple ways. I understand, but I want to explain it. There are multiple ways that you can solve this. Now, last week when you guys had your quiz, you guys did what with this? So what's one way that we could solve this that you did on your quiz last week? So you did 2 squared times what? Okay, and then what did you do from there? So since the square and square root crossed out and canceled, I need you to have a seat. I'm in the middle of talking right now. I understand you want to show me the answer, but you're going to have to be patient. So when the square and square root cancel, it gets rid of that square root sign, where we're left with just 2 times 5. And then 2 times 5, as Michael already let us know, is going to be 10.
Yep. I got it right.
Now, it's not always, you guys aren't always going to have where it works out perfectly like that. Okay? So we're still kind of... Okay, so example number 1 and example number 2, we've already did. We did something like that last week. Go ahead and write out example number 3. Example number 3 is not going to be review from last week. Example number 3 is going to have something new added.
No,
Okay, so if you guys remember, square and square root cancel one another out. So what I want you guys to do here are circle your pairs. Remember, pairs are groups of 2. So if we go through to circle our pairs, I'm going to circle what? I'm going to circle my 2's, and then what?
Circling 3s.
So I'm going to circle my 3's. Does that work?
Yes, no.
Why doesn't it work?
Not easy.
Because it's not a pair. So I can only circle 2 of my 3's, and then one of my 3's is going to be left out. It does not have a pair. Remember, when we say pair, pair means 2. When we say square, square means 2. Square cancels out with square root. So what we're going to do with this problem here is that we're going to show that this square cancels with the square root. And this square cancels with the square root. Meaning that these numbers, so this square cancels the square root, this square cancels the square root, so they're not going to be under the square root sign anymore. So I'm going to be left with just a single 2 times a single 3 on the outside. Because one of my pairs canceled with the square root, that moves to the outside. One of my 3's canceled with the square root, that moves to the outside. Now, there's one problem though. I still have a number under the square root sign, right?
I thought you just used that number to make that 3.
It can't because it's not part of the pair. Because I have a number that's still on the inside of the square root sign, I'm going to have to leave that on the inside of the square root sign. Okay? So the number that's inside of the square root sign, we talked about that last week. That's called the radicand. It's going to stay the radicand. The numbers that we move to the outside are going to be called the coefficient. Now, my answer is not in simplest form yet. I'm not done with this problem. When I say my answer is not in simplest form yet, what can I do to continue solving this problem? Which equals? Yep, so 2 times 3 is 6, and then square root 3. Because there's nothing that we can do with that square root 3. So this is where we're talking about simplifying square roots. Because it is not a perfect square, because it did not work out evenly, this is an example of simplifying a square root that is not a perfect square. Because that 3 did not have anything to cancel with the square root sign, it's stuck inside the square root sign. Now these got to move to the outside as a single number because their second number canceled with the square root sign. Okay? So what I have on my sheet up here, you guys want to make sure you have on your sheet so that when you go to use a quiz or a test or you use this for homework, you have all the information necessary. Okay, let's look at example number 4. Let's put that aside for now. Let's look at example number 4. So we're going to write the square root of 2 times 3 times 3 times 5 times 7 times 7. once you have that written down, circle your pairs. So once you have that down, go ahead and circle your pairs. Now make sure you put that square root sign in there because it's going to be important. Some people sometimes forget to put the square root sign, and that changes the makeup of our question and answer. Okay, so
Bless you.
raise your hand if you can tell me what pairs I have here. Kaylon.
You got 3 and 3.
Okay, so I'm going to circle those and
7 and 7.
okay. Now,
And then don't you gotta cross it out?
because square cancels with square root, which means my second number cancels with the square root sign. And where does that go now?
To the end.
To the
Bottom?
outside.
Yeah.
We move it to the outside. So I'm going to move 3 times 7 to the outside. What numbers did not have a pair?
2 and 5.
So what happens with those?
You gotta put that little box.
Put the square root sign,
The box.
put the square root sign, and
2.
good. 2.
No.
Yeah.
Yeah, top.
So that stays inside the square root sign. Those stay my radicans.
You got it?
Now, I'm not finished with it quite yet because I need to simplify it. Simplify it means just solve it. So I wouldn't leave an answer 3 times 7, square root 2 times 5. What should I do?
2 times 1.
Yeah, what's 3 times 7? We're going to multiply our outside numbers. 21. And then I'm going to put my square root sign, and I'm going to multiply my radicals. What's 2 times 5?
10.
So your final answer is going to be 21 square root 10. So the only way I read it is 21 square root 10. Not 21 times square root 10, just 21 square root 10. Now,
So is it,
I took 2 times 5.
So at the end, you gotta multiply like
At the end, now sometimes, that's a really good question, Damon. So sometimes you might only have one number that you move to the coefficient position. And if you only have one number that you move to the coefficient position, you're not going to have to multiply it by anything. It just depends on what numbers we use. So before we do some actual square roots where I'm going to make you factor, because basically I gave you guys the factor of numbers. Before we move to the other examples, I want to take 2 parts of notes here. The first part, we're going to talk about terminology. It's going to be very important that you guys understand the proper terms, because if you don't, you're going to get really confused. So the terminology that we're talking about. So if you look at the bottom of your notes, you have 3 square root 2. So the number 2, or the number that's on the inside, that's called the radicand. So you're going to write that in the box. The inside number is called the radicand. So my inside number is called the radicand. Now, I've already told you guys what the outside number is called. Who remembers? Nope. The outside number. That 3, the number that's on the outside of that square root, does anybody remember what I called it?
And again.
Perfect square.
Started with a C.
Sorry, the city.
You guys, I love y'all. The coefficient. Oh, did you?
I like coffee.
You mumble so much, right?
Coffee's in it. Yeah.
That's one way to memorize it. Now, I know I've thrown a lot of terms at you today, but you have to know, when I say the outside number or coefficient, it's this number that's no longer in the square root. The number that's on the inside is the radicand. Okay, flip your notes over. Now, I have not made you guys write a whole lot of actual notes. Okay, usually it's just like a couple of words or a sentence. Because this lesson is so very important, I'm going to have you guys write down 4 steps for when you're simplifying square roots. I always have a kid, do we have to write it all? Yes. The reason why you have to write it all is 1, incomplete notes does you no good. If you get down into your LS class and Miss Harris is like, I don't know how Miss Littleton wants me to do that, all you have to do is grab your notes. The step-by-step explanation should be able to teach anybody how to do it without being in class. 2, when you go to take the quiz on Friday, Mr. McFarland is not going to be allowed to help you. I'm going to tell him no. Because he already passed high school. He knows how to do this. I need to know that you know how to do this. But I'm a terrible test taker. I see a test, I'm like, oh, I forget everything. But if you use your notes, you have everything there. So, what I'm saying, write it all down. So step 1 for simplifying square roots. The first thing that you're going to do is factor the radicand. And you're going to rewrite the radical with its prime factorization. Now, I'm going to show you what that looks like in just a minute. But we already know how to factor. So we're okay. So we're really only learning one new thing today. Because you guys know how to factor. You know how to find pairs. The only thing you're learning new today is if it's not a perfect square. Step 2. You guys have done this already. Circle your pairs of factors in the radicand. Step 3. Each factor pair in the radicand becomes a single factor in the coefficient. And step 4. When I say simplify, what I'm talking about, multiply your insides, your radicands, and multiply your outsides, your coefficients. Okay, so example number 5. We have the square root of 48. So, notes aren't good at all if you don't use them to help you solve it. So step 1 says factor the radicand. When it says factor the radicand, that's where you guys do your factor tree. So the first thing that we're going to do, because it's a 2-step step, we're going to factor the radicand. So we're going to make our factor tree, right like this. We've already done this stuff before. So what 2 numbers can I multiply together to get 48?
6 and 6.
6 and 8. Or 2 and 12. Or, 2 and 24. There's all different ones that you can use. We're going to use 6 and 8. Okay, what do I do next?
You make the tree again on the 6 and on the 8. Then you
Okay, and circle my 2 and my 3. Kalan, what do I do for 8?
you do 4 and 4. No, 4 and 2.
Okay, then what?
Then you circle the 4.
No, not.
No, you circle the 2, and then you make the tree again on the 4. And you do 2 and 2.
Okay. So that's good job. That's the first part of step 1. Now the rest of step 1 says rewrite the radical with its prime factorization. All that means is that we're going to come up to the right of it here. We have to put my square root sign because we haven't gotten rid of that. And we're going to put those numbers that we circled in standard form. Okay? So these numbers are our prime numbers, our prime factorizations, and we're going to put them in least to greatest, which is going to look like
2, 2, 2, 2, 3.
now.
Don't you gotta circle the...
Not yet. I want to explain something to you. If you have numbers that are not under that square root sign, you have to make your square root sign long enough so that it covers all those numbers. Okay? Because it's part of the square root. I don't want you guys to forget the numbers that aren't under the square root sign. So that was all step number 1. Step number 2. What's step number 2 say to do? Yeah, so circle the pairs. What are my pairs here? I have a pair of 2s, another pair of 2s.
Oh, but last time we had the 3. Alright, bro.
Okay. Now, we're ready for step 3. Okay, so after we circle our pairs in the radicand, each factor pair in the radicand becomes a single factor in the coefficient. So each factor pair in the radicand becomes a single number in the coefficient because square and square root cancel. So I'm going to put in my coefficient, how many 2s am I moving to the outside?
2.
Yeah, so it's going to look just like that. And what's going to be stuck on the inside still? The 3. And then my last step says simplify. So simplify means multiply the outside numbers together and you get, multiply the inside numbers, you get 3, yeah. And that's your answer.
That is too long.